right, so far so good. We've got great keyboards. They'll play the fourth octave, so we have 7 keys that are all working. But that's not very many keys. We want to increase that number. So we incorporate into our piano an octave button at the top there and 3 octave LEDs. And we're going to be able to use those when we push that button. It'll shift all 7 keys to the next octave higher. So the 5th octave, and if we push it again, it'll shift them way down to the 3rd octave. So we'll be able to get 21 different notes with our keys, as well as the potential of having all of those sharps and flats as well. Okay, so before we do that, we need to set a bunch of stuff up. So I'm opening up my piano file that we already created, and I'm going to create some pen modes. So I know I'm going to need one for the button. So Control C, Control V. And this one, let's call the pin that the button is in, let's see, the octave button pin. And I've misspelled that. And of course, because I'm using a new variable, I'm going to copy that and come up here and create a new variable up here, int. That's an integer to create an integer variable, Control V. And we're going to set that to wherever you've plugged your octave button into. For me, that is number 9, pin 9. So I'm going to put a 9 here and colon here and put a comment in. Creates a variable for the octave button. All right. And now we're going to come down here and do another pin mode. So Control Z. I'm going to copy and paste this pin mode command. And I'm going to change this one to the octave 3 LED pin. And I'm going to change this to an output, because now we're going to be actually sending electricity to the LED using this pin. And maybe I just do Oct3, make it a little bit shorter. And now I'm going to copy and paste this. And of course, I'm using a new variable here, so you need to come back up to the top and create a global variable for it. Control V. And my pin number is, I used 10, 11, and 12, I think in that order. So 10, creates a variable to store, or how about 4, for the octave 3 LED pin. Awesome. And now I need to do this 2 more times for the 4 and 5, and those are just repetitive. So I'm going to come here, enter this one, and then change the 3 to a 4 and the 4 to a 5. And I need to go back and create these 2 variables as well. So I'm going to take my variable up here and I'm going to copy and paste it. Whoops. Where is it? Here. Copy and paste 2 more times. Change this one to a 4, this one to a 5, and 11 and 12. All right, so now later on, to remember that I need to make sure these are the right ones, because 3 might not be in pin 10, depends on how I wired it. I think I wired it that way, but if I find they're turning on at the wrong times, I can come back here and change it here in one place, and it fixes it all through my code. So it's the value of using these variables here. And then, yeah, I think that's it. I think that adds our button and our 2 pins. And then what we're going to do next is create a little test. So I'm going to open up a space inside void setup because I want the test to run just once. I'm going to put a comment in right away, and then I'm going to do the following code. Runs a quick test of the LEDs and speaker. All right. So we actually have a speaker test right here. So I'm going to come grab this, Control X to cut it, and I'm going to bring it down below this comment. So we're going to turn the speaker on and leave it on for 1,000 seconds here, playing. I'm going to kick it down to 1,000 hertz. And then we're going to turn the LEDs on. So we're going to do a digital write. If you spell it right, it should turn green. Mine did not. I misspelled it. It used to be where if you did it right, it turned orange, but now with a new program, it turns green. Digital write, we need to tell it which pin to do. So we're going to do LED 3. Let's turn it on, comma, and then the last command for write, you need to say whether it's going to be high or low. And because it's digital, it only gets a high or low value. Put a quick comment in, and this turns LED 3 on. Well, let's do turns Octave 3 LED on. Okay. And we'll do the same thing for 4 and 5. This is just a quick test. And we'll pin 4 and 5 on. And then let's do a quick delay. And I'll do 1,000 millisecond delay. I'm going to have it match the tone of the speaker. So once the speaker turns off, these lights will be on for the time the speaker is running. How about that? And now we need to turn them back off. But I'm going to start with my octave value in 4. So that's going to be my starting place always. So I'm actually going to leave 4 high. So I just want to turn, so I'm going to take one of these. Whoops, I need to change this one to 4 and this to 5. Digital write Octave 3 LED pin. I'm going to change this one to low. And then I'm going to add another one below it. And I'm going to change this one to 5 and make it low as well. And then 5, and both of these should be off. All right, so I tested out. So I turned the speaker on for a second. I turned the lights on for 1 second, and then I turned 3 and 5 off, leaving 4 on. So that's my indicator pin for what's going on. All right, so that's my test. Let's go ahead and run that and see if your lights are working. If your lights aren't working or your speaker isn't working, it's a good thing to run a test for. So I'm going to upload this code to my Arduino. When it uploads, I should hear 1,000 frequency tone for 1 second, and my 3, 4, and 5 lights should light up. If not, maybe you've wired your oh, that was just it. I had all 3 lights light up for a second, and I heard the tone, and now 4 stayed on. So everything's working perfectly. If one of your lights didn't light up, the first thing to do is just kind of wiggle around the wires and resistors, make sure nothing's touching each other inappropriately. And if that doesn't work, then you might want to switch the legs of your LED. So maybe you plug them in backwards. I did that on all of mine. I put the positive into ground and the ground into positive. Switch those, see if that works. If none of that works, ask for help and I'll help you. All right. So now we've got our test, and it'll run every time, and it only runs once because it's in void setup. That's why you put it up in void setup. It just runs a quick test so we know everything's working. All right, so next thing we need to do is we need to read the octave button. So we need to read whether it's been pressed or not. So to do that, I'm going to open up some space at the top here, and I'm going to do, this is plugged into a digital pin, so I'm going to do a digital read, because for this button there's only either all on or all off. So digital read. It should turn green if you spelled it correctly. And we just need to tell it which pin to read. So if I look at my octave, I see that I plugged it into pin 9. In fact, I already know that because I already created a variable for it up here. I'm going to come up here, copy my octave button pin, and put it right there. Now remember, Arduino is incredibly stupid. When it goes through this code, it will do a digital read, and it will say, oh, button is low, no one's pressing it. Great. And then it will instantly forget that information. Or it'll go and someone's pressing it and they'll go, oh, button's high. And then it will instantly forget that. So we've got to tell it where to store that information if we ever want to use it again. And we do that by putting a variable out in front. So here, let's call this one octave button val equals. So this is the value of the button, whether it's high or low. And because we're creating a new variable, we need to go create the new variable. So Control C. I'm going to come up here to the top, and I'm going to create an integer variable. Whoops. I'm going to do int octave button val equals, and I think probably the best way to start this one out is at low or 0. So this creates a variable for the high or low value. Of octave button. Okay, so this will keep track of it for us. So now we're reading whether it's high or low, and then we're storing that in here. So let's put a quick comment here. So reads the voltage on octave pin and stores it in the variable octave button val. Not a big fan with the new program environment that it breaks your comments down to the next line like this. I think it makes the code harder to read. I wish they would just go off the screen. But you can see it's not a new line of code because this here is an open space instead of a new numbered line. So that tells you it's not a new line. But I think visually it makes it harder to read. Yeah, can't do that. All right. Let's see. Okay, so now we need to, let's actually print this. So let's see if it's working. So I'm going to come down here and find this serial print here that we had before. I'm going to click anywhere on that line and do Control/. That will comment it out. So hold down the Control key while hitting the slash, which is the key right next to Shift on the right-hand side of your keyboard. That will hide this so it won't print it anymore. And here on line 34, I'm going to enter a new line in, tab over once. I'm going to do serial.print ln for new line, and I'm going to print the octave button val so we can actually see it. And if spelled correctly, serial will be orange and print ln should be green, and then semicolon. And let's put in a quick comment here, // maybe we do displays the octave button val on the serial monitor. All right, so let's upload this code and just see if our octave button is working. We should see it go from 0 to 1 as we press the button every time. So that's my test of the setup. My lights turned on, my speaker went, so that's good. And did it again. And now it's printing out zeros for me. If I push the octave button, the zeros turn to 1. Mine's a little sluggish, so it's a little slow to turn, but I can see that it's working. Awesome. Okay. So I'm going to close out that serial monitor now. And then I'm going to come down here. Now that it's working, we need to have, we're going to use the button to cycle us through to higher values in the octave. So we're going to start out at octave 4. If we push the button, we're going to go to 5. If we push it again, we're going to actually cycle back to 3. But let's just see how this works. So I'm going to do this with an if statement. So if octave button val, put that in here, is equal high. Now equal is something different than equal. So equal means take whatever's on the right and put it in the variable on the left. So it's a writing command. It's like take this thing and put it in that variable, erase what's there and replace what's new. The double equal is asking a question. It's saying, is the value currently in octave button val, is it equal to high? Is it the same as high? It's going to return one of two things, either true, they are equal, or false, they are not equal. In this case, if it's true, if this returns true inside here, it's going to run the code inside the if statement. To get the inside the if statement, we do an open curly brace. Notice how Arduino's already entered in the closing curly brace for us. So I did open curly brace and then an enter. And notice how it's opened up this space here and put the closing curly brace down here. So if this is true, if the octave button val is currently high, it's going to run this code. And the code that we're going to run is going to be octave val I'm trying to think of how I want to do this. Yeah. We're going to create a new variable called octave val. So we're going to store which octave we're in, whether in 3, 4, or 5. And we're going to set that, well, let's just do plus plus. No, let's do a more thing. We're going to do this octave val plus 1. Make sure, yep, they're not spelled the same. Let me make sure I've got them the same. There we go, octave val. So octave val equals octave val plus 1. So this is an example where the equal sign definitely isn't an equal. What it says is take whatever's over here. So take the current value in octave val, add 1 to it, and then shoot it over here and put it in this variable octave val. So erase what was there and put the new stuff there. Because we know from experience that octave val can't equal octave val plus 1. That's like saying 3 is equal to 3 plus 1, and that's just not true. So this is not an equal. It says take whatever's over here and put it in the variable on the right, or left, sorry. Now, we just created a new variable called octave val, so we need to create that variable up top. So up here, we're going to create a new variable, integer, control V, and we're going to set that equal to 4, which is our starting octave, and semicolon. All right, now let's go ahead and see how this works, and we'll see if we can, every time, so if it's high, it should count up by 1. So every time we push the button, it should count up by 1. Let's see how well this works out. So I'll load this code, and then we'll open the serial monitor. That was my test code coming up, and I'm ready to open the serial monitor. Oh, except we didn't do a print. Oh, come on, Mr. Oz. All right, so first of all, we need to actually print the octave val down here. So we're gonna hide this serial print. So click on anywhere here, control / that'll hide it. And then inside here, no, we'll do it down below. That's totally fine. We're going to add in another serial print. So serial dot print ln, and we're going to serial print octave val. So it's going to show us what our octave val is. Should have done this before. Little semicolon here, and maybe we put this down. The same comment down here displays the octave val on the serial monitor. All right, now I'm going to upload that, and now it'll actually be serial printing. Notice how once I use a serial print and I see that it's working, I go ahead and comment it out. That way I don't have a bunch of data on the screen making it confusing. I usually have 1 or 2 things printing on the screen at a time. Again, I just uploaded, so I know that's working. And now I'm going to open up my serial monitor, and we'll see where octave val is. Hopefully it's at 4, because that's what we said we wanted to start at. Yep, so it's starting out at 4, and if I press the button, it should, ooh, I see an issue. So mine's a little sluggish, but you can see I don't go up by 1, I go up by a lot. And if I hold the button for a long time, I go up really fast. So what you're seeing here is the code is so fast that even if I press the button once, it's going through the code multiple times and seeing it be high several times through the code. So the only way to make this work is either press the button insanely fast, and even then I'm going up by 10, or we've got to fix it with code. And that's what we'll do in the next videos. We'll start with figuring out how to make a button work and not read multiple times for a single push. All right, awesome job so far. We'll see you in the next video.